Nuclear reactor is a system that contains and controls sustained nuclear chain reaction, split atoms and use the energy obtained to produce huge amount of electrical power. The nuclear reactor works mainly due to nuclear reaction, which are nuclear fusion and nuclear fission. Nuclear fission occurs when the splitting of a large atom into two or more smaller atoms. Nuclear fusion occurs when two or more lighter atoms combine into a larger one. Uranium atoms are split and release energy in the reactor. Control rod in the reactor is used to control the speed of the chain reaction. Water is pumped through reactor to collect heat energy produced in chain reaction via heat exchanger. Inside heat exchanger, water from reactor gives up its energy to cooler water flowing in another closed loop, turning it into steam. The steam from the heat exchanger is pumped into a turbine. The turbine turns at high speed. Spinning turbine is connected to electricity generator and makes that spin too. Finally, the generator produces electricity. There are two types of nuclear power plants, which are boiling water reactors and pressurized water reactors. Pressurized water reactors keep water under pressure so that it heats but does not boil. This heated water is circulated through tubes in steam generators, allowing the water in the steam generators to turn to steam, which then turns the turbine generators. In boiling water reactors, the water heated by the friction actually boils and turns to steam to turn the turbine generator. The steam then turns back into water and can be used again in the process. Advantages are low greenhouse emission. Nuclear reactor does not emit carbon dioxide and methane gas, which can contribute to global warming. It is also reliable. Nuclear reactor can work in extreme cases, unlike solar and wind energy, which require sun and wind as conditions to produce energy. However, the disadvantages are high cost because it takes a long time and expensive to build a nuclear power plant. The nuclear waste from the nuclear power plant emits radiation, and the nuclear waste can sustain over 100 years. According to a survey carried out by the Association of Water and Energy Research Malaysia, only 2.2% of Malaysians are confident that nuclear power plants are safe. This shows that many of the Malaysians are worried of the nuclear power plants. Thus, the possibility of having nuclear power plants in Malaysia are low. The benefits of having nuclear power plants are: nuclear power plants can produce much less greenhouse gas for each unit of electricity produced compared to those produced by fossil fuels. Malaysia are facing the problem to have expert workforce to manage nuclear power plant facilities. This factor already limits Malaysia to build nuclear power plants. According to the survey carried out by the Association of Water and Energy Research Malaysia, 79.34% of Malaysians are not confident that Malaysia has expert workforce. According to an article in the Sun Daily, the feasibility of study of nuclear power plant in Malaysia has slowed down after Fukushima nuclear accident in 2011. The public lost confidence in the government ability to prevent such incidents. Thus, feasibility of nuclear power plants has been slowed down. In my opinion, we are against on building nuclear power plant in Malaysia due to it will bring serious damage to surrounding if any nuclear accident happens. So, Malaysia is not ready yet to build the nuclear power plant. In 1986, Chernobyl, Ukraine occurs a nuclear accident where destruction of the reactors by steam explosion and fire killed 31 people and had significant health and environmental consequences. The disaster is caused by the serious mistake made by the operators. The thermodynamic analysis related to the nuclear power plant is Brayton cycle. Below are the Q diagram and TS diagram of Brayton cycle. Below are the flow diagram of simple gas turbine. First, air are collected from the atmosphere. After air is compressed in the compressor, it is transferred to regenerator. Regenerator uses the heat from house gases to heat the compressed gas before going into combustion chamber. The fuel is added to the combustion chamber. Combustion happens and hot gases is obtained. Shaft of the turbine is rotated by the hot gases. Rotating turbine shaft rotate the compressor shaft to produce electricity. The heat from exhaust gases is then recovered in the regenerator.
Created using Powtoon.